All right, so in this lesson, we're going to talk about how to find the equation of a tangent line. So remember, the tangent line is a line that kind of touches the circle, all right? So that would be the point of tangency, where the tangent line touches the circle. Okay, so let's kind of take a look. So exercise 1, so given the segment AB with endpoints at A and B, we're going to answer the following questions. So this is going to we're going to do a quick review on how to find an equation. You're going to see why we're going to talk about what we're going to talk about, because it's a very similar process of how we would find the equation of a line to find the equation of a tangent line. Okay, so let's first determine the slope of AB. So remember, slope is y2 minus y1 over x2 minus x1. So 6 minus negative 3 over 3 minus negative 3. So 6 minus negative 3 is 9 over 6. So we get 9 divided by 6 is 3 over 2. So for part B, determine the slope of a line perpendicular to AB. So remember, slopes of perpendicular lines are negative reciprocals of each other. So the negative reciprocal of 3 over 2 is just negative 2 over 3. So for C, write the equation of a line that passes through point B and that is perpendicular to AB. Okay, so we're going to use this point and this slope. Now, when we have a slope and a point to determine an equation, we're going to write y. We're going to use our point slope form. So y minus y is equal to m times x minus x. So we're plugging in point B, we're plugging in this slope. So y minus 6 is equal to negative 2 over 3 times x minus 3. So we get y minus 6 is equal to negative 2 over 3x plus 2. So plus 6, so we get y is equal to negative 2 over 3x plus 8. So the y-intercept is 8. All right, so let's take a look at more of like the circle part of this. So circle A is shown below with center at the origin and a radius of 5. Point B lies on the circle and has coordinates of 4, 3. The tangent to the circle at point B is drawn. So this is the point of tangency. Okay, so we're going to write the equation of the circle below and show that 4, 3 must lie on it. So our center is 0, 0. So x squared plus y squared. Now we need our radius. So our radius is 5, but remember our equation is set equal to the radius squared. So the equation of this circle is 25. Now 4, 3 must lie on this. If we plug this in, it shows that 16 plus 9, so 25 is equal to 25. Okay, so now we're going to find the slope of AB. So the slope of AB, so A is the center, and B is 4, 3. Okay. So we get 3 minus 0 over 4 minus 0. So our slope of AB is 3 over 4. Okay, so we're going to write the equation of line M in point slope form. Now, the tangent line, remember, is perpendicular to the radius, right? One of our little circle rules, this right here is a right angle. So the point of tangency, when a tangent line is drawn to the radius and they meet at the point of tangency, it's perpendicular, okay? Now we're going to use the point of tangency. So we're going to use point B, 4, 3. And we also need the negative reciprocal of 3 over 4. So we're using, slope we're using is negative 4 over 3. Okay. So our equation will be y minus 3 is equal to negative 4 over 3 times x minus 4. Now you can go ahead and put it in slope-intercept form, but since they just asked for an equation, I'm just going to leave it like that. Okay. All right, so let's look at part D. So part D, it appears that line M has a y-intercept of 8. Prove or disprove this observation. Okay, so let's simplify it then to show that, or to prove or disprove that there in fact is a y-intercept of 8. Okay, so clearly not y-intercept, not 8. Okay, so sometimes it looks like it has a y-intercept, an even y-intercept, but in this case, it does not. All right, so let's look at the next page. All right, so consider the circle whose equation is this and 0.25. Show that A must lie on the circle. So if it's on the circle, if we plug this point into this equation, then it's going to equal. Then the left side is going to equal the right side. So let's plug this in. So 2 minus 6 squared plus 5 plus 3 squared is equal to 80. So this is 16 plus 64. So 80 is equal to 80. Okay. Before we do the next part, I'm going to graph the circle. So the center is 6, -3. Okay, now here's the thing. The radius is the square root of 80, which is not even. 80 is not a perfect square. So when we take the square root of 80, we get 8.94 blah, blah, blah. So when we count the radius, when we figure out kind of where the circle is, we're going to count close to 9, but not quite. All right, so let's, starting at the point, we're going to count up 8, 1, 2, 3, 4, 5, 6, 7, 8, and go a little, almost all the way, but not quite. So let's go this side too. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm going to take my compass. Draw a circle like that. Okay. So now a point A is 2, 5. So point A is here. Okay, so now for part B, we want to find the slope of a line segment that connects the center of the circle to point A. So we want to find, we're going to call this C for center. Okay, so we're using 6, -3. We're using point A, which is 2, 5, to find the slope. So 5 minus -3 over 2 minus 6. So 8 over -4, which is -2. All right, so now we want to write the equation of a tangent line to the circle at point A in point slope form and slope intercept form. Okay, so here is the tangent line at point A. And that is the equation of the line. That's the line we want to find the equation of. So remember, the radius is perpendicular to the tangent line. So the negative reciprocal of -2 is 1/2. And we're passing through point A. So we're using A, which is 2, 5. Okay? So let's plug this into my point slope form. So y minus 5 is equal to 1/2 times x minus 2. So we get y minus 5 is equal to 1/2 x minus 1 plus 5 plus 5. So y is equal to 1/2 x plus 4. Okay. All right, so let's look at exercise 4. So given the circle whose equation is x plus 4 squared plus y minus 2 squared is equal to 136. Write the equation of the tangent to the circle at point this. Okay, so here's the thing. We don't necessarily need to know the radius for the circle. It doesn't really matter. The only thing that matters is the center point and the point of tangency. Okay, so the center point is negative 4, 2, and we want to use 2, 12. Okay, I mean, now, yeah, it's helpful to visualize to see, but you don't necessarily always need to do that. You just, again, like I said, in order to find the equation of a tangent line, two things that matter is the center and the point of tangency, the point it's passing through. The tangent line is passing through. Okay, so let's first find the slope of the radius. So slope of the radius. Okay, so 12 minus 2 over 2 minus negative 4. Okay, now we need the slope that's perpendicular to it, so the negative reciprocal. So negative 3 over 5. Okay, so now we're doing our point slope form. So we're using this slope and this point. So y minus 12 is equal to negative 3 over 5 times x minus 2. And since it's just asking for the equation, we don't need to go any further. You can if you want to, but I'm just going to leave it like this. Okay. All right, something else I want to go through with you guys is how to construct a tangent line. Okay, so we're on page 41. So we're going to kind of skip this. I'm just going to show you a couple examples. So for this one, we're just going to construct a normal tangent line. Now, remember, the tangent line is perpendicular to the radius. Okay, so our first step in constructing a tangent line is we're going to start off by drawing a line starting at the center and passing through the point that we need our tangent line to go through. So start something like that. Okay. Now I want to draw a line perpendicular. So I'm going to construct the perpendicular bisector. Now when we construct a perpendicular bisector that needs to go through a certain point, we do it a little differently. So what I want you guys to do is make your compass, I mean, you don't have to make it like terribly small, but just like, doesn't need to be a crazy big either. So put your compass point on point A, and you're going to draw a circle. I'm going to draw a circle like that. I mainly just want a circle so that it intersects this line twice. So something like that, okay? Now, using these two intersection points that I just found, I'm going to do the perpendicular bisector of this line. So I'm going to make my compass halfway. I'm going to do an arc like that first, and then I'm going to do an arc like that. Now I'm going to draw a line down the middle, and that is my tangent line. Okay? All right, so now let's do another one. Now, this time we're going to construct two tangents that connects with the exterior points. Okay? Now, this one's a little more involved. Okay, so what I want... Okay, so what we need to do first, so let's start with point Q. So we're going to draw a line from the center to point Q. Okay. Okay, so now what we're going to do is the perpendicular bisector of this line. Okay. So like that, and like that. We're going to draw a line down through the middle. So what this is going to do for us is this is going to create like a midpoint of this line. We're not done yet though, because we want a tangent line, so something like lines that connect from point Q, touching the circle and touching this way too. So what we're going to do is we're going to put our compass point on point M. Now we're going to measure out the distance to the center of the circle from the midpoint. Okay? Now what we're going to do is we're going to draw a circle around the midpoint. So like that. Now that circle we just drew is this one right here. Now this circle intersects the black circle, the one we were given, the one we want our tangents drawn to, twice. It intersects it here, and it intersects it here. This is where we're drawing our tangents. This is where we're drawing our tangents to, okay? So now we're going to draw a line starting at Q to this point, and we're going to draw a line starting at Q to this point as well, okay? So that's one. Now let's do the other. So again, starting at P, we're going to draw a point from P to A. Okay. So now we're going to do the perpendicular bisector of this line. Okay, and we're going to do the perpendicular bisector of, no, perpendicular bisector. We're going to do two half circles in each direction. So this is the perpendicular bisector of line PA. We're going to draw our line down the middle and mark our midpoint. Now we're going to do the same thing. So starting at M to A, we're going to draw a circle around it. Now again, this circle intersects the black circle twice. Here and here. And we're going to do the same thing with Q. We're going to draw a line from P to this point and a P to that point. So these two lines are the tangents from P, and these two lines are the tangents from Q.